Welcome back to Talk Tensors, our deep dive into the world of cutting-edge machine learning research. And today we're going to be looking at a paper titled TrajectoryCrafter, Redirecting Camera Trajectory for Monocular Videos via Diffusion Models.
Sounds complicated.
It is, a bit. But at its heart, the idea is actually really cool.
Okay, I'm listening.
Imagine you got a video, right? Like something you shot on your phone.
Yeah.
And then imagine you could create entirely new videos from that same footage, but with the camera moving in any way you want. Like picture yourself making these smooth cinematic orbits around a subject, or a dramatic zoom, all after the fact, just from that one original video.
Oh, wow. That would be pretty amazing.
Exactly. It's about creating these more engaging, immersive visual experiences. And that's exactly what TrajectoryCrafter aims to do.
So this paper, why is it creating such a buzz in the machine learning world?
Well, for starters, it tackles some really fundamental challenges in novel view synthesis. So traditionally, if you wanted to create new perspectives on a scene, you'd often try to reconstruct a full 3D model of it.
Right.
But that can get really tricky, even impossible, when parts of the scene are hidden in the original recording.
Makes sense.
And then came along these generative methods using diffusion models, which have shown a lot of promise. But they've mostly been applied to static scenes, still images. Applying them to dynamic videos where things are moving and giving users precise control over the camera's path, well, that's been a real hurdle.
Yeah, I can see how that would be much harder.
Yeah. Now, you might have heard of GCD.
Vaguely.
Right. It's a related approach, but it often runs into trouble when dealing with real-world videos. It's trained on these synthetic data sets, and that gap between the training data and the real world can cause problems. Plus, the camera control in GCD isn't as direct or intuitive. TrajectoryCrafter really tries to overcome these limitations.
So TrajectoryCrafter comes in and solves all these problems.
It aims to, definitely. The authors lay out three main challenges. First, giving users that precise control over the virtual camera's movement. Second, ensuring what they call 4D consistency in the generated video.
4D consistency?
Yeah, meaning that the content and the motion stay believable across time, and those new viewpoints. Like if someone is walking left in the original video, they should still be walking left in the new view at the same speed, looking the same, all that.
Right. So it's about making the scene look plausible, not like some weird jump cut.
Exactly. And the third challenge is about training this model on a massive, diverse data set so it can work well with all sorts of different videos.
Okay, so how do they actually go about tackling these challenges?
Well, the real breakthrough in TrajectoryCrafter is how it separates two key processes: determining the new camera viewpoint and then generating the visuals from that viewpoint.
Interesting.
So they start by taking the original video and basically lifting it into a 3D point cloud.
A point cloud? What's that?
Think of it like this. They estimate the depth of every visible thing in each frame of the video.
Yeah.
And they use that depth information to create a sparse 3D representation. So it's not a full detailed 3D model. It's more like a cloud of points scattered in 3D space representing the scene.
Okay, starting to get the picture.
And the cool thing is, this point cloud is dynamic. It changes as the video plays, capturing the movement in the scene.
I see.
So once you have this point cloud, you can define a new camera trajectory, like the path you want your virtual camera to follow, and render new video frames from that moving perspective.
Sounds pretty clever. But wouldn't those rendered views have holes or missing parts? Especially in areas that were hidden in the original video.
You're absolutely right. That's a big issue. And that brings us to the second crucial part of TrajectoryCrafter: their dual stream conditional video diffusion model.
Dual stream?
Yeah, meaning it processes information in two parallel streams. So one stream works with those rendered point cloud views we just talked about. And because these are based on estimated 3D geometry, they provide very precise information about the new camera position, like where it is in relation to the scene. But then the second stream works directly with the original source video.
Interesting. So they're using both the 3D information and the original footage.
Precisely. And that second stream is crucial for ensuring that 4D consistency we mentioned earlier.
I'm starting to see how this all fits together.
It's like one stream is taking care of the camera position based on the point cloud, and the other stream is handling the actual video content from the original footage.
And that second stream fills in the gaps, makes sure everything moves naturally and looks right in the new view, even in those areas that might have been hidden before.
Exactly. So two streams working together to create a more complete and believable result.
That's pretty impressive. But to train a model this complex, you'd need a ton of data, right? Like video shot with multiple cameras at the same time to capture all those different viewpoints.
Yeah, you would think so. But here's where their approach to training data gets really interesting. They didn't have access to these massive, perfectly synchronized, multi-view video datasets. So they had to get creative.
Okay, how did they do that?
They used a hybrid strategy, two different types of datasets.
Go on.
First, they tapped into these huge web-scale datasets of regular monocular videos, the kind you find all over the internet.
Right.
But to make this data useful for their task, they came up with a clever double reprojection technique.
Double reprojection.
Yeah, so imagine taking a regular video and rendering a new view from it using an estimated point cloud, kind of like what their model does.
Okay.
But then they take that new view and project it back to the original camera's position.
So they're basically creating these synthetic training pairs where you have something that resembles a point cloud render with those characteristic holes and the original video as the target.
You got it. And by doing this, they're essentially teaching the model how to predict what those point cloud renders should look like, given a regular video, and how to fill in the missing information realistically.
That's really smart. So they're making the most of what's already out there. And what about the second type of data?
The second type comes from static multi-view datasets, where you have multiple cameras capturing the same scene simultaneously from fixed positions. For this data, they use these advanced 3D reconstruction techniques to get accurate point clouds and the corresponding video frames from each camera.
So this gives them these clean training examples, right? Where you have a source view, a target view, and a high-quality point cloud that connects them.
Exactly. And by combining these two data types, the vast but potentially noisy monocular data and the smaller but more precise multi-view data, they're able to train a model that's both accurate in terms of view transformation and robust enough to handle all kinds of real-world video content.
Really clever. And does the paper show that this approach actually works?
Absolutely. They put TrajectoryCrafter through its paces, testing it on existing multi-view datasets. And, what's really impressive, they created a whole new benchmark, a larger, more diverse one, using real-world and AI-generated monocular videos.
Wow, they really went all out.
Yeah. And the results are really compelling. They used quantitative metrics like PSNR, SNC, LPIPS, all these standard measures to compare the generated videos with the original ground truth videos. And their qualitative results, the visual comparisons, also show that TrajectoryCrafter outperforms the current state-of-the-art methods like GCD, ViewCrafter, even those reconstruction-based methods like shape of motion.
So they've got the numbers and the visuals to back it up.
Exactly. And they didn't stop there. They did these thorough ablation studies. That's where you remove different parts of the model to see how each component contributes to the overall performance.
Right, got to make sure it's not just one magic trick doing all the work.
Precisely. And those studies confirmed that their dual stream architecture and their data strategy are key to getting these great results.
So we've got a pretty good handle on what TrajectoryCrafter does and how it works. But how does this fit into the bigger picture of novel view synthesis research? Like, where does it stand in the history of this field?
That's a really important question because it helps us understand the significance of this paper. So the field of novel view synthesis has, well, it's come a long way. Early on, researchers were really focused on these traditional geometry-based methods.
Okay.
The idea was to, build a 3D model of the scene and then render it from different viewpoints.
Yeah.
But these methods often struggled with fine details, reflective surfaces, and especially with those hidden areas we talked about earlier.
Right, the parts you couldn't see in the original view.
Exactly. And then along came neural networks, these powerful new tools, and we saw the rise of implicit neural representations like neural radiance fields or NERF.
NERF, yeah, I've heard of
The
it.
NERF was amazing at synthesizing new views, but mostly for static scenes, still images.
Yeah.
Extending that to dynamic scenes, videos, was a whole other challenge.
Because now you've got motion to deal with things changing over time.
Exactly. So early attempts at dynamic novel view synthesis often relied on having multiple videos captured simultaneously, or they'd use depth estimation from a single camera to try and warp existing views. But these methods were limited. Complex motion, new information that needed to be generated, it was all really hard to handle.
Okay, so where do diffusion models come in?
Diffusion models have been this game changer in AI, really. And it was only a matter of time before they were applied to novel view synthesis for both images and videos. But early diffusion-based methods for videos had their own set of problems. They often struggled with maintaining consistency over time and achieving that fine-grained control over the virtual camera's movement. And that's where TrajectoryCrafter really stands out. It takes these powerful diffusion models and builds on them, addressing those limitations specifically for dynamic scenes, using just a single regular video as input.
So it combines the best of both worlds, kind of, the geometric accuracy of traditional methods and the generative power of diffusion models.
That's a great way to put it. And they're not the only ones using this kind of separation of concerns approach. It's been really successful in other areas of machine learning too, like separating style and content in image generation.
Yeah.
So TrajectoryCrafter, it's part of this bigger trend.
It's fascinating to see how all these different areas of research are influencing each other.
Absolutely. And it makes you wonder, where could this all lead next? And that brings us to our Novel Notions segment, where we like to speculate a bit about potential future directions.
Always fun to think about the possibilities.
So one intriguing idea is to explore more interactive and user-guided approaches to trajectory redirection. Right now, with TrajectoryCrafter, you define the camera paths after you've shot the video.
Right.
But what if we could get real-time feedback from the user during the process? Like, imagine the model is generating the new video, and the user can say something like, hey, focus more on the person's face for the next few seconds, or smooth out that jerky camera movement.
So you're talking about a system that can respond to those instructions and adjust the trajectory and the generated video on the fly.
Exactly. And that could involve using reinforcement learning, where the user's feedback is like a reward signal, guiding the model to refine its output. Or you could have these interactive editing tools that let the user manipulate the virtual camera path directly and see the results instantly.
That would be really cool. And it fits with this whole trend of controllable generation in AI, right?
Absolutely. And TrajectoryCrafter lays the groundwork for making this kind of interactive video manipulation a reality.
Okay, that's one interesting direction. What other research avenues come to mind?
Another area that's ripe for exploration is improving the scene understanding that underlies all of this.
Yeah, because if the model doesn't understand the scene properly, things can get weird.
Exactly. And the authors themselves point out that sometimes inaccuracies in depth estimation can lead to less than ideal results. So, future research could focus on incorporating more sophisticated scene understanding techniques.
Okay, like what?
Well, this paper focuses on using just a single video, but you could imagine using data from other sensors too, if available.
Right. More information is usually better.
And even within the realm of monocular video, you could leverage advancements in video object segmentation, object tracking, incorporating semantic information about the scene, all those things.
So the model would have a richer understanding of the scene, knowing what objects are where, how they're moving, all that.
Right. And that could lead to more robust and accurate results. Like, imagine the model being able to handle transparent objects like glass properly, or being able to track individual objects through complex motions without losing track.
So it's about pushing the boundaries of what's possible with scene understanding to make this kind of video manipulation even more powerful and reliable.
Exactly. And who knows what other creative applications people will come up with once this technology becomes more widely available. It's exciting to think about.
Definitely. So to wrap things up, let's recap the key takeaways from the TrajectoryCrafter paper.
Sounds good.
TrajectoryCrafter offers this new, powerful framework for creating videos with user-defined camera paths from a single input video. Its strengths lie in that clever separation of view transformation and content generation, using dynamic point clouds and that dual-stream diffusion model. And their data strategy, combining different types of data, is crucial for making it work well in the real world. Their evaluations show it outperforms existing methods, and it opens up a whole bunch of exciting research directions for the future.
Couldn't have said it better myself. It's a real step forward, and it has big implications for how we create and experience video content.
And on that note, here's a final thought for our listeners. With this increasing ability to manipulate camera perspectives in video, how might that change how we interact with our own video archives, or all that online video content we consume? What new forms of storytelling might emerge?
Those are some great questions, something to ponder. You can find a link to the TrajectoryCrafter paper in the show notes. Thanks for joining us on Talk Tensors for another deep dive. Until next time.